Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. The topic for today's video is going to be how you can automate the startup and shutdown of EC2 virtual machines that you spin up inside of your AWS account so that you can see a cost optimization when those EC2 instances aren't actually needed. This is a great technique for any EC2 instances that are typically in a non-prod environment because if a developer spins up an EC2 instance and they only need that instance during the day when they're actively developing software and deploying updates to their dev virtual machines, then you can shut those down when they're not actively consuming them, and you can actually see a pretty significant cost savings. Right. So out of 24 hours in a day, if you're only using a EC2 instance for 8 hours a day, you're only really using a third of its capacity. So why have it provisioned for those extra 16 hours when you're only using it for 8 hours every single day, right? So we can see kind of a potentially 66% discount on our EC2 instances just by shutting them down when we're not actively utilizing them. So really quickly about StratusGrid, if you go to stratusgrid.com, you can learn more about our company here. We're an AWS Premier Consulting partner. Also, we're an independent software vendor. We have a FinOps tool here called Stratosphere. And what Stratosphere allows you to do is to identify cost optimization opportunities across your cloud environments. And then you can actually take action on those cost savings opportunities and then go back into Stratosphere and update the status on those findings so that you can keep track of all of the savings that you've actually implemented inside of your cloud accounts. So if you're interested in learning more about Stratosphere, go to stratusgrid.com and you can check out our website right here, or feel free to reach out to us and we'd love to talk you through it and show you a demo and show you how easy it is to get onboarded into Stratosphere. So let's go ahead and talk about today's topic. What we're going to do is head over into the AWS Management Console here. We're going to set up a brand new EC2 instance, and then we're going to take a look at how to set up what's known as an event bridge rule or schedule that you can use to automatically trigger different API actions in AWS. Of course, a couple of those actions that we're going to be using are the start instances and stop instances APIs for the EC2 service specifically. So let's go ahead and start by just launching a new EC2 instance in our account. So if you head over to instances, and I'm going to be operating in the US West 2 Oregon region right here. So just make sure that you're operating all in the same region because the rules that you create are regional. The EC2 instances are regional. VPCs are regional. So just make sure that you're working in the correct region. That's something that's really easy to mess up if you're new to AWS or just typically only work in a single region. So what we're going to do is head out to the launch instances wizard here, and we're going to make a bunch of customizations to this instance. Now, one thing I want to call out is that when you're provisioning an EC2 instance, if you're commonly using the spot instance type, which allows you to see like a 75, 80%, sometimes even more than that, discount on your virtual machines in EC2, then you have to make sure that the spot instance is set to persistent and not one time, because one-time spot instances can't actually be stopped in your account. You have to have a persistent instance in order to stop that virtual machine. So we'll talk about that when we get to the advanced options down here. But I'm just going to create a virtual machine here called Trevor EC2 YouTube Auto Startup. And then I'm going to choose the Ubuntu image right here. And then once we do that, we're going to choose the ARM-based CPU architecture here because I want to use the ARM-based Graviton CPUs instead of the Intel AMD CPUs that are more traditional. And then for our instance type down here, once the console refreshes here, we're going to choose the T4G instance type. So it looks like the AWS console is being a little bit slow here. So let's go ahead and force a refresh. Then we'll type a name, Trevor Dev YouTube 01, choose Ubuntu, and then we'll choose the ARM architecture here and see if it works this time. So yep, we get this screen that says confirm changes. And that'll just change the AMI that we're using because the AMI has to be either ARM or x86 compatible. So we'll go ahead and use that. And then for the instance, I'll just choose something like a T4G micro. Doesn't really need to be very large. We're probably not going to log into it anyway, but just in case, I am going to assign an SSH key pair right here. So let's go ahead and assign an SSH key pair just in case we do decide we want to log into it later on. I'm going to choose a VPC that I created that is custom, that has IPv6 and IPv4 enabled. So we'll go ahead and enable that. So we get auto assign public IPv4 and auto assign IPv6. You could also create IPv6 only subnets in VPC where you actually don't have IPv4 at all and you can have IPv6, but I actually have a separate video on that on my personal YouTube channel, so feel free to search for that. So if we go select a security group here, just in case I want to SSH into it, I have an inbound rule for TCP port 22, just in case I decide that I want to SSH into this VM and do some additional configuration. The storage down here doesn't really matter too much because, again, we're not going to be installing anything on there or copying any files to it. For the instance profile here, you don't have to put an instance profile. This is basically an IAM role that gets bound directly to the EC2 instance, so that if you're running any code on that EC2 instance that calls out to AWS APIs, you can actually just kind of pass through credentials from that role that are dynamically generated rather than having any kind of static credentials. So typically what I do is I have a role here that I bind to the EC2 instance that has permissions to the AWS Systems Manager service, so that if I forget when I'm provisioning here, sometimes I forget to assign an SSH key pair here. And so if I do forget that, I can always access an interactive shell on that server by using the Systems Manager Session Manager service. So that's a nice backup option to have just in case I forget that SSH key pair. Now, the more important option here for cost optimization is purchasing option. So I like to use spot instances whenever possible. I just default to spot instances unless there is a very specific reason why I cannot use spot instances. Maybe you have an application like a database server that always needs to be available, right? In a production environment, that could be a great use case to use on demand and then either purchase an AWS savings plan or a reserved instance to cover that instance with a discount. But if you are creating these kind of temporary virtual machines in EC2, then using spot instances is a great option here because you get a huge discount, again, somewhere in the range of 70 to 90% typically to really bring down your AWS spend. So when we do the customize spot instance options here, we're going to choose the persistent option because, again, if we choose that one-time option, we're not going to have the option to stop the virtual machine. But if you create a persistent request for a spot instance, you will get that option to stop the virtual machine. Something else to note with spot instances is that if you are provisioning GPU-based workloads, then if you try to request a spot instance for like the G series or the P series of virtual machines that have NVIDIA GPUs attached to them, then you oftentimes are going to have trouble getting spot instances. But when you're spinning up just typical compute instances like the T4G, the T3, C7G types like that, you're typically not going to have much of a problem getting spot instances. So if you are spinning up G series or P series EC2 instances, then just be aware that you might have a little bit of trouble finding spot capacity. At least I have in the past. If they increase the capacity of their data centers with additional G and P series instances, then maybe we'll see spot instances open up in the future. But if you do get an error when you try to launch an instance and it says, hey, there's no spot capacity available, either try a different availability zone by changing the subnet that you have assigned here in the VPC. So you can see I'm using US West 2A, and I could just change it to a subnet that's in US West 2B or 2C or 2D, however many availability zones there are. I'd have to actually go out and create subnets for those additional AZs, but at least I have two different AZs that I'm using subnets for in A and B. So just be aware of that. And I don't think we really need to customize any other options here. So we're just going to go ahead and choose the launch instance button right over here, and that will create our new instance. Now, it looks like I forgot to set one option here, which is the instance interruption behavior. So let's just scroll back down a little bit further here, and we will go ahead and customize the spot instance options again. So yeah, I forgot to choose the interruption behavior here. We'll just choose to stop. So if AWS reclaims that capacity for our spot instance to a customer that wants to pay the full on-demand price, then we'll just stop that instance. And then when the capacity becomes available again, we can go ahead and just restart that instance. And you can only do that if you have persistence here. Otherwise, the instance will just disappear. So what we're going to do is go ahead and just hit launch instance here again, and hopefully we get a nice little green box indicating a successful launch, which you can see right there. So if we head over back to instances right here, you'll see that we have this brand new instance running right here. You can copy the instance ID either right here by selecting it, or you can just go down to the details screen at the bottom, and next to the instance ID field, you can just click on the copy button there. That'll copy it to your clipboard so that we can use that when we create an EventBridge schedule. Now, if we head over to the Amazon EventBridge service here, this is the service that has since been renamed from CloudWatch Events. So Amazon used to call the EventBridge service CloudWatch Events, and all of the event bus functionality, which I actually covered in another video on the StratusGrid YouTube channel. Feel free to look at that if you're curious about how event buses work. But one of the features in the CloudWatch Events legacy service that got moved over to EventBridge is the ability to create what are called schedules. So in the schedules service here, essentially what we do is we create a one-time or a recurring schedule so that we can perform an API action one time, sometime in the future. Like maybe we want a one-time action that starts up a whole bunch of virtual machines on a specific Saturday because we're going to be doing some maintenance on them. So you can kind of pre-schedule things on a one-time basis, or you can set a custom recurring schedule that periodically executes different API actions. It uses cron expressions, so you can get very, very granular with exactly when those schedules are going to execute. What we're going to do here is create a brand new schedule. I'm going to give this a name. Actually, before I do that, I want to create what's called a new schedule group. So if we go to schedule groups right here, you can kind of just create these logical groupings. And this is a good idea just for categorization. I'm just going to call this group Trevor Sullivan, and I can associate a resource tag with it just so all my teammates know what is going on with this resource and who owns it, who's responsible for it. So now that I have that schedule group in my account right here called Trevor Sullivan, we can go back to schedules and say create schedule. Let's call this Trevor EC2 start instance. And we'll just say this starts my dev EC2 instance every weekday at 7 a.m. local time, which is when I typically start my day. And then I'll choose the schedule group here to assign this new schedule that we're creating to my personal group. Of course, you could create schedule groups by team or some other logical grouping as well, but I'm just going to create, since this is a dev account, I'm just going to create a group for myself here. And then under the schedule pattern, this is where we can specify if we want a one-time schedule or a recurring schedule. Now, when you choose recurring schedule here, it's by default going to use the time zone from your local system. So I'm in the Mountain Time Zone in the United States. So it's going to choose the America Denver location there. And then you can either use what's called a rate expression, where you can say, hey, I just want you to do something every 4 hours. But if you want to be really specific about the time of day and the days of the week and the months and the years that you actually want this schedule to execute, then you can use a cron expression. And these are very, very powerful. So what I could do is say every morning at 7 a.m. So that would be 0 minutes. So the 0th minute of a particular hour at the 7th hour of the day. And again, that's going to be local time here. So we already have the UTC offset here. The day of the month, we're going to specify star here because we want every single day of the month, right? So it doesn't matter if a Tuesday falls on the 1st of the month or the 28th of the month. We don't really care. We just want it to run every single day, but we're going to restrict it to the days of the week. For the month here, we're going to put I think we actually need a question mark right here and then a star here. There's a couple of different wildcards that you can use, and you can refer to the documentation over here. There's a separate section called Amazon EventBridge Scheduler. In the documentation, if you go out to EventBridge docs, there's EventBridge user guide, and then there's Amazon EventBridge Scheduler user guide. So even though the EventBridge service is kind of one umbrella service, there's actually kind of 2 different user guides here. So make sure that you are looking at the correct one. If you go to the general EventBridge user guide right here, and go down to scheduler. This gives you an overview of the scheduler service, but if you want details about the scheduler service, you actually have to go over into the EventBridge scheduler documentation here, and then you get a whole different tree structure here for the user guide, so just be aware of that. But if you drill into the scheduler specific documentation and go to schedule types, this actually gives you some really detailed information about how the cron expression works right here. So the question mark is only valid on a couple of different fields. It's valid on the day of month, and it's only valid on day of week. So what we're going to do in our cron expression right over here is make sure we use question mark instead of asterisk for day of month. And then for the day of the week, what you can do is, again, look at the documentation right here. So what we can do for day of week is say something like Sunday to Saturday or Monday to Friday or whatever days of the week, or you can use the numeric value. So I could say like 2 to 6. So 2 is Monday, 6 is Friday. So I could say from any day, Monday to Friday, I want you to run this. So it's up to you if you want to use numeric values like 2-6 indicating a range of values, or we could say Monday to Friday like that, abbreviated. And then for year, we're just going to use an asterisk because we don't really care what year it is. If it's 2024, 2025, 2026, we want it to run for every year. Or we could put a range like 2024 to 2026, because for whatever reason after that, we're not going to use this schedule anymore. So you do have the ability to specify a range of years there as well, if you'd like to. But then what's nice about the console is that it shows us the next 10 trigger dates here. So we can see that our cron expression here is valid. So it's going to run at 7 a.m. next Monday. It's going to run at 7 a.m. next Tuesday. It's going to run on Wednesday, Thursday, and Friday. And then check it out. It skips Saturday and Sunday because we have days of week here. So day of month, we don't care about the specific day of month. If it's the 1st of the month, or if it's the 20th of the month, if it's the 22nd of the month, because Monday to Friday falls on different days every single month, right? And so we don't care what the day of the month is. Maybe in some cases you do, but for this use case, we just want to run it during weekdays. So we don't care about the day of the month, but we do care about what day of the actual week it is. So that's how we're able to specify Monday to Friday and exclude the Saturdays and Sundays. There's another option down here called flexible time window. So you can set an offset of like up to 5 minutes or up to 15 minutes. So if you don't want the schedule to run exactly at 7 o'clock every single day, you can say, well, you can have up to 15 minutes of leeway. And it says right here in the documentation, your schedule runs within a certain period of time after your specified time. So it could run from 7 a.m. all the way up to 7:15, or any time from 7 a.m. to 8 a.m. if I choose a 1-hour flexible time window here. But I'm just going to set that to off for now. And then you can also limit the time frame if you'd like to. And this is for daylight savings time here. I'm not going to specify that at all. So we're just going to click on this next button right down here in the bottom right. And this is where we can specify the target of our event bridge rule. Now, for the use case that we're discussing in this video, we are going to be starting and stopping an EC2 instance. And these are very common API calls that are available in the EC2 service. So if we go to all APIs, and we filter for the EC2 service in particular. And then within the EC2 service that we're now in these breadcrumbs right here, we're going to search for start. And you can see we have an API call right here called start instances. And then we can paste in the instance ID that we copied from the EC2 console. And you can always go to services and middle click EC2 while you're creating the rule. And then you can just tab over to that and go to instances and just grab that instance ID right here. You can just copy that if you forgot to, and just paste that right back in here. And then we'll close that EC2 tab because we don't need that anymore. And then after we configure the target, we'll say next. You want to enable the schedule, so you can create a schedule and either leave it enabled or disabled. If you just need to temporarily disable it, maybe you go on vacation, you want to leave the rule in place, but you want to be able to disable it while you're on vacation because you don't need access to that EC2 instance during your PTO. And then down here, we have the action after schedule completion. So what this allows us to do is to automatically delete the schedule after it executes. This is really more useful for one-time events where you want to schedule something off in the future. And after that one-time schedule runs, just automatically clean up the rule, because once it executes that one time, it's no longer valid. But in our case, we actually want a recurring rule to continually run every day, right? So it wouldn't really make sense for us to delete the rule after it runs, because then the rule is no longer valid and it's not going to do what we expect it to do. So of course, we're going to choose the none option here for this use case. And down here, we have the option to retry. So for some reason, the API call were to fail, you can just have it automatically retry. and you can say, what is the maximum age of the event? Maximum is 24 hours right now, but we could drill that down to maybe just like an hour or maybe just like 15 minutes or something if we want it to retry up to 15 minutes or so. You can tell it how many times you want it to retry. So maybe just retry a single time. I'm going to go ahead and leave that disabled and assume that it's going to be fairly reliable. The other option that we have down here is to set what's called a dead letter queue. So if there are any failed events, then what we can do is actually create an SQS queue inside of the same region here, and then we can forward those failed events to that SQS queue, and they'll just stay in that queue until you write a custom application that reads the messages off the queue and does some kind of custom logic. So you could send yourself a Slack message, you could send yourself an email, you could log it to a database somewhere and report on it. Whatever you want to do with that dead event is up to you, but that's what the dead letter queue is for. It just allows us to take any failed events and just send them off to a queue so that we can write some custom logic for how to handle those failed events. All right, we're going to skip over the encryption options here because this is all taking place in AWS. I don't really see a need to do encryption right here. But for the permissions down here, this is probably the most important section from a security perspective, because what this allows us to do is to select an IAM role that gets bound to this rule in EventBridge. And this is going to specify that we need permissions to the EC2 service. So let's search for EventBridge here. And I have a couple of existing EventBridge roles, but what I'm going to do is actually go ahead and create a new role for this particular task and make sure that it has permission specifically to the EC2 APIs. So what we're going to do is create a new role. We're going to go ahead and specify a service here. We can specify event bridge. And if we choose event bridge, then this is going to allow EventBridge to access the secrets manager. So this is not what we want. They still have a legacy CloudWatch events option here as well. So if we choose that template, it's going to have some default access to CloudWatch event services. This is kind of a legacy policy here because in the trust policy, it actually has events.amazonaws.com. But the trust policy here actually needs to trust the scheduler service, not the traditional legacy CloudWatch events service. So unfortunately, they don't have a good template here. So what you typically want to do is just create a custom trust policy here. And so I'm going to use the CloudWatch events as a template, and then we'll actually go in and edit the trust policy later on. So I'll just give this role a name like Trevor-EventBridge-EC2 startup shutdown. And then we'll go ahead and give it a tag so that my teammates know who owns it. And then we'll create the role. And then once we open up that role, we'll say view role, go to the trust relationships here, and then we'll say edit trust policy. And I'm just going to copy this entire JSON blob here under the statement, put a comma after it, make sure you put a comma there, and then just paste it again. And what we're going to do is change the principal that's trusted to scheduler.amazonaws.com instead of events.amazonaws.com. So we'll go ahead and allow those two services. We'll say update the trust policy. And now our trust relationship will allow the EventBridge scheduler service to utilize this IAM role. The other thing that we need to do, though, is go to permissions, and we need to make sure that we add the necessary permissions to allow this rule to start up and shut down EC2. So we could create a very granular policy, but I'm just going to go ahead and skip that for now. We'll just say EC2 full access. Generally, you're not going to want to use this because this allows lots and lots of different actions, but for the sake of demonstration, we'll just use that rather than crafting a detailed granular custom policy. And now that we have access to the EC2 APIs, we can now close this tab and come back to the EventBridge scheduler service right here. We'll go ahead and just click on the refresh button here so we get a fresh list of IAM roles. And then I'll search for EventBridge, and sure enough, Trevor EventBridge EC2 startup shutdown. We'll choose that role there, click on next, and then we can go ahead and scroll down to the end right here, and there's a button to say create schedule. So we'll click on that. All right, so now we've got this brand new rule that starts my dev EC2 instance every weekday. We can see what the target is right over here, along with the payload that contains our instance ID in EC2. Also, keep in mind this is a JSON array, so if you want to add additional EC2 instances to that array, you can specify those instance IDs right there if you'd like to. And so now the only other thing that we would need to do is basically to create another rule to shut things down. So this is the more important one because this is actually what's going to save us money on our spend. We'll call this Trevor EC2 dev shutdown. We'll say shuts down EC2 dev instances at 4 p.m. local time. We'll add that to the same schedule group. We'll use a recurring schedule. So the minutes are going to be 0 because we're going to do it at the top of the hour. The hours are going to be 16. So that would be 12 p.m. noon plus 4 hours is 4 p.m. That's going to be the 16th hour of the day. We're going to do question mark star Monday to Friday again, just like we did before, and an asterisk. And so this is going to run every weekday. So like later today, today's a Friday. So at 4 p.m. today is the next time that it would run. Flexible time window, turn that off. We'll skip over the time frame option here. And then for all APIs, we're going to again search for EC2, click on EC2, and then say stop and choose stop instances. And again, we're going to plug in our instance ID right there. And if we wanted to, we could do a comma and paste in a second instance ID as well, or third or fourth, or however many you want to. And then we'll say next, and then we'll leave that schedule enabled. We'll choose no action. We don't want to delete the rule after it executes. Let's just disable the retry policy to keep things simple. For the role, again, we're going to search for Event Bridge, and we're going to choose the startup and shutdown role that has access to the EC2 APIs. We'll hit next, and then just create the schedule. So now, if we go back to schedules right here, you can see we have two different schedules. They both belong to the same schedule group. So if we click on that schedule group, we can see the different metrics related with it that show how many invocations were attempted, how many were dropped, any errors related to that, and things of that nature. So there are some useful metrics that you can get here from the schedule group level. But if we go to the rules section in the left-hand nav here, go down to schedules, we can see all of the individual schedules that we have created right here. So now we have a shutdown at 4 p.m. and we have a startup at 7 a.m. So basically everything is set up at this point. So all we have to do at this point is wait until 4 p.m. local time, and then the scheduler service should go ahead and shut down our instance. And then the following Monday, after this weekend at 7 a.m. local time, it should go ahead and start up this instance. So if we'd like to test this out, what we can do is just edit the cron schedule a little bit here. And so it's currently 10:06 a.m. So I'm going to say at 10:07 a.m., we want to go ahead and shut this down. And hopefully I can finish editing this before it turns into 10:07. Let's go ahead and save that schedule. And it looks like, according to my local computer's clock, it still has not turned 10:07 yet. So let's head over to the EC2 service right here. Take a look at our instance. It's currently running right here. And so in just a few seconds, we should eventually see that this instance automatically starts to stop, begins the stopping process. So let's do get date right here. And it looks like in a few more seconds here, at least according to my local computer clock, not necessarily the AWS cloud clock, it is going to now turn 10:07. So if we just refresh our view right here, we should eventually see that it's now in the stopping state. So that was our event bridge rule that triggered automatically at the appropriate time frame. And so we've verified that our IAM role has the necessary permissions because it was able to stop that instance at the correct time. So that's how you can set up an automated schedule to stop your instances and start your instances. I will also point you to another option that's available. So there is something called the EC2 instance scheduler, which is right here. And so the instance scheduler is a pre-built AWS solution that you can deploy into your AWS account that allows you to perform a lot of the same actions. But the thing is that this solution is very complex. There's lots of moving parts here. There's DynamoDB tables, there's Lambda functions, there's all sorts of custom integrations here. And so this is a much more complex solution, but there is documentation on how to actually use it. So if you're looking for a really simple solution, then go ahead and just use the Event Bridge service. But if you need a more complex solution that can scale to multiple teams or multiple individuals, that is kind of built in a standardized fashion, then the EC2 instance scheduler option for AWS here is a pretty cool solution. They do have this implementation guide here in their documentation that talks about how to deploy the solution and then how to create custom schedules inside of the DynamoDB table. So we might do a separate video on this. There's also a CLI tool that goes along with this as well if you'd like to use that. But this is a whole topic in and of itself. So feel free to check out the instance scheduler if you're interested in more of an enterprisey solution than manually creating the schedules in the Event Bridge service. So anyway, that's pretty much everything I had for this video. Please leave a like, please subscribe to our channel to get notified about future videos that we come out with, and also feel free to reach out to us to get a demonstration of the Stratosphere cost optimization tool. Head over to stratusgrid.com and check out all of our documentation on that. Feel free to check out our knowledge base here as well, and feel free to share a link to our YouTube channel and our website here with your other team members and any other industry contacts that you have. We would love your ongoing support. So thanks again for watching, and we'll see you in the next video. Take care.